All right. Good morning, everybody. Welcome back. Another week, another chance to get better. Okay, so for this week, we will have to cover a little bit more of nomenclature for the covalent compounds, and maybe we can start next chapter on Friday. All right, so let's start with some quick announcements here for the week. You have online homework chapter 2 part 2 due on Thursday. Okay, so I might extend this due date depending on how fast we can move this week. So I will keep you in the loop. And for this week, we will not have in-class assignment this coming Friday. Okay, so we will meet here on Zoom on Friday for regular lecture. All right, with that being said, so let's move on. So we are talking here now about covalent bonding and thus covalent compounds. In covalent compounds, there is involvement of two or more elements that need to gain electrons. And it's based on the concepts of sharing electrons. So at this point, we will not care too much how the electrons are being shared. We just need to identify a covalent compound and name this compound. Covalent bonding is usually formed between elements from groups 13, 14, 15, 16, 17, 18, or hydrogen, okay? Any combination of elements that belong to those groups will form a covalent bonding. And covalent compounds, they are subdivided in oxides, acids, and molecular compounds. Our goal for this week is to recognize any of those subdivisions and name the compounds as well. Okay, so let's start with oxides. That's the first class of covalent compound that I will show you. For that, I will switch to my other screen, then I can write. Just a second. Okay, so oxides, they have a general formula: element bonded to oxygen. So E here stands for any element, and O stands for oxygen. So element bonded to oxygen, that will be classified as an oxides. Pay attention to one important detail. The net charge of an oxide is always zero. CO2 is an oxide, but CO3 2 minus is not. Okay, so CO2 is an oxide because the net charge of the compound is zero. However, CO3 2 minus is not an oxide because the net charge is different from zero. Okay, so pay attention to that, especially at the end of the week, because I will show you a lot of compounds and you have to be able to recognize when you have an oxide and when is not an oxide. How we name those compounds? Very simple. First step, the first word is the name of the first element in the formula. Second step, the second word is oxide. And third step, use prefixes to indicate the number of atoms of each element in the molecule. Attention here, do not use the prefix mono with the first element. So for oxides, you will need to use prefixes to indicate the number of atoms because there will be more than one combination possible between two elements to form an oxide. For example, when we combine carbon and oxygen, we can have one carbon to one oxygen or one carbon to two oxygens. So we need to differentiate between those two combinations. And that's why we are going to use the prefixes to indicate the number of atoms in the formula. So I want to do two examples with you, CO and CO2. Let's try to name those compounds. So let me give you some time to take notes, and then we will name those compounds together. Okay, so let's start with CO. CO is an oxide because we have an element bonded to oxygen and the net charge is 0. Now let's name this oxide. First step is to name the first element in the formula. So here is the first element is carbon. So that's going to be the first word, carbon. And the second word is going to be oxide. Third step, you have to use prefixes to indicate the number of atoms of each element in the molecule. Attention here, do not use the prefix mono with the first element. So let's add the adequate prefixes. We just have one carbon. Therefore, we don't need to use the prefix mono. And we have just one oxygen. Therefore, we have to indicate the number of oxygens, and that's going to be added here before the word oxide. Therefore, the compound CO is carbon space monoxide. Some people like to write with the double O, and some people like to write with just one O. I prefer with just one O because it makes it simpler. So therefore, CO is carbon monoxide. Now let's see the case for the compound CO2. Again, CO2 is an oxide. An element bonded to oxygen and the net charge 0 characterizes an oxide. Nomenclature, name of the first element. Again, we have carbon. The second word is always going to be oxide. And now we are going to use the prefixes to indicate the amount of each element in the formula. Never use the prefix mono with the first element. However, we need to indicate the number of oxygens in the formula. In this case, we have 2. The prefix for 2 atoms is di. Therefore, CO2 is carbon space dioxide. All right, so the nomenclature for oxides is quite simple. You just need to be able to identify when you have an oxide, pay attention to that, and then follow the 3 steps to name the oxide. Attention when you need to use the prefixes to indicate the amount of atoms in the structure. Okay, so I just showed you examples to name a given formula, but of course, you have to be able to do the opposite. With the name, you must be able to write the formula, okay? So it shouldn't be too complicated. Okay, so let's move on to the next class of compounds, of covalent compounds. So just a second. So let me switch back to the PowerPoint. Okay, so now I will show you acids. For acids, there are 2 subdivisions. The first class of acids is called hydracids. Hydracids are formed when you have hydrogen bonded to an element, and this element X is usually an element from groups 15, 16, or 17. So those are the hydracids. The second subdivision of acids is called oxoacids. Oxoacids are formed when we have hydrogen an element X and oxygen, okay? HXO. And the element X is usually an element from groups 13, 14, 15, 16, or 17. Okay, so acids, they are basically characterized as hydrogen bonded to an element. If we just have hydrogen and one element, this is going to be a hydracid. If we add an oxygen to the structure, then we have what we call oxoacids. Okay, so let me start showing you first the hydracids, and then we will move on to oxoacids. All right, for hydracids, hydrogen bonded to an element from groups 15, 16, or 17, nomenclature of this kind of compound. First word in the nomenclature to indicate that this is a hydracid, we use the word hydro. The second part of the first word is the name of the parent element. In this case, the element that's bonded to hydrogen, except that the ending is changed to IC. And then the second word is simply the word acid. When we are dealing with acids, we do not use the prefix mono, di, tri, and etc., etc., etc. Therefore, the name of a hydracid is going to be hydro, name of the parent element with the ending IC, space, acid. Let's do here two examples, HCl and H2S. Let me switch again to the other screen. Okay, so let me do the two examples with you. First one is HCl. So look at the formula and you have to immediately identify which class this compound belongs. Hydrogen bonded to an element from groups 15, 16, or 17 is going to be a hydracid. So HCl is a hydracid. Oops. That's the first thing. Okay, so now let's name this compound. Follow the instructions here. First word is hydro. Hydro is going to be followed by the name of the element, except that the ending is changed to IC. So we have here chlorine. Therefore, we are going to add the name of the element. However, the ending we are going to change to IC. So instead of chlorine, is going to be chloric. Okay, see the change here. So therefore, this makes up for the first word, hydrochloric. Give a space, and then the second word is simply acid. Therefore, HCl is hydrochloric acid. Okay, so now let's see H2S. So when you have sulfur, it's a little bit trickier, but you should be able to do it without any problems. First word is hydro, because we have hydracid. The second word is going to be the name of the element, followed by IC. So we have here sulfur. In this case, we are going to add IC at the end. So that will become hydrosulfuric acid. Okay, so one thing you have to pay attention. Sometimes you will see HCl as hydrogen chloride. Hydrogen chloride is HCl in the gas state. However, when we have HCl dissolved in water, that will receive the name of hydrochloric acid. Okay, so attention to that. And the same thing with H2S. You may find the name of H2S as hydrogen sulfide. That is only valid when we have H2S in the gas state. Once H2S is dissolved in water, this becomes hydrosulfuric acid. And to make things simpler, we always are going to work with these compounds dissolved in water. Okay? So just careful with this little detail. And again here, I gave you the example starting with the formula and naming the compound, but of course you have to be able to see the name of the compound and go back and write the formula of the compound. All right. Okay, so sorry about the back and forth here. Let's move back to the PowerPoint. Okay, so now let me present you the second class of acids, which are called oxoacids. And here, the general formula is going to be hydrogen, an element X, and oxygen. This element X usually belongs to the group 13, 14, 15, 16, or 17. Oxoacids are a little bit trickier than hydroacids. So let me see if I can break down for you. Nomenclature. For the first word, the second part of the first word is the name of the parent oxoanion, XO, except that the ending is changed to IC. And the second word is simply the word acid. And again here, do not use the prefix mono, di, tri, tetra, and etc. to indicate the number of atoms in the structure. Therefore, you are going to use the name of the parent oxoanion followed by the ending IC, give a space, and then write the word acid. Okay, so the trick here is to first recognize the oxoanion, and second, know exactly the name for the most common oxoanions. To help you first recognize and remember the formula and name of the oxoanions, I will show you a trick. And that's going to be the Nick the Camel. So let me open here for you. So I will put this document on Canvas. And this is a trick to remember the 5 common oxoanions that we are going to work with. And that's the Nick the Camel ate a clam super in Phoenix. So the trick here is first, the underlined letter represents the symbol of the first element in the oxoanion. Second, the number of consonants represents the number of oxygen atoms present in the oxoanion. And third, the number of vowels represent the number or the magnitude of the charge of the oxoanion. And because it's an anion, it's always negative. So Nick the Camel will give us the formula for the 5 common oxo anions that we are going to use. So let's see how that works. Let me give you some time. All right, so let's see here the example. So Nick, the underlined letter represents the symbol of the first element. So therefore, we have here N for nitrogen. The number of consonants represents the number of oxygen atoms in the structure. So here we have 1, 2, and 3. So therefore, we have 3 oxygen atoms, NO3, okay? First letter, number of consonants, 3, and that represents the number of oxygens in the structure. And the number of vowels is the number of the charge of the anion, just one vowel, therefore 1 minus charge. So that means Nic stands for the oxo anion NO3 minus, and this oxo anion is formed by nitrogen. Nitrogen, therefore, the name of the oxo anion is going to be nitrate. Okay, and then C will stand for the carbonate ion, chlorate ion, S for the sulfate ion, and P for the phosphate ion. Okay, so again, I will make this file available on Canvas. So let me go back to the other screen, and then we can write the formulas here. Okay, so here the trick is to first recognize the oxo anion, know the formula of the oxo anion, and then we name the compounds. Okay, so always try to use the Nick the camel to remember. So the first letter here is going to be the first element. This element is always going to be followed by oxygen, because we are looking at this part of the structure. Okay, the number of consonants is going to be equals to the number of oxygens in the structure, 1, 2, and 3. And then the magnitude of the charge is equals to the number of vowels. just one vowel. Therefore, we have a 1 minus charge. Therefore, NO3 minus is the nitrate ion. Camel. The underlined letter is C. So that means we have carbon, always going to be followed by oxygens. The number of oxygens in the structure is equals to the number of consonants in the word. We have 1, 2, and 3 consonants. Therefore, we have 3 oxygens. The charge of the anion is always going to be negative, and the magnitude of this charge is equals to the number of vowels in the word. Camel has 2 vowels, therefore charge 2 minus. CO3 2 minus is formed by carbon, therefore this is the carbonate ion. Okay, so for now, we are just looking at the XO part of the structure. For clam, the element here is going to be Cl. Always followed by oxygen. The number of oxygens has to be equal to the number of consonants, 1, 2, and 3. There is always a negative charge, and the number of the charge is equals to the number of vowels in the word. 1 vowel, 1 minus. ClO3 is formed by chlorine. Therefore, the name of the ion is going to be chlorate ion. Next one is super. That means we have S for sulfur, followed by oxygen always. The number of oxygens in the structure is equals to the number of consonants, 1, 2, 3, and 4. There is always a negative charge, and the number of the charge is equal to the number of vowels, 2 minus. SO4 2 minus is formed by sulfur. Therefore, we have here the sulfate ion. And finally, Phoenix. We have here P, that stands for phosphorus, always followed by oxygens. Number of oxygens is going to be equal to the number of consonants, 1, 2, 3, and 4. The magnitude of the negative charge is equals to the number of vowels, 1, 2, and 3. Therefore, PO4 3 minus, PO4 3 minus is formed by phosphorus. Therefore, the name of the oxo anion is phosphate ion. Okay, oxoacids are very tricky. First thing is to remember the standard, use the Nick the Camel, identify the formula of the oxoanion. So I showed you the most common that we are going to work with: nitrate, carbonate, chlorate, sulfate, and phosphate. And then we are going to be able to name the oxoacids. So let me show you two examples here, and then we might be able to finish for today. So the two examples I would like to show you are H2CO3 and H3PO4. Okay, so first thing, we have hydrogen, an element, and oxygen. That means we have an oxoacid. The trick here for oxoacids is to identify the oxoanion. The oxoanion is always going to be everything you have in the formula except the hydrogens. Okay, so for H2CO3, the oxoanion is CO3 2 minus, which is right here. The name of the oxoacid is going to be started with the name of the oxoanion, except that the ending we are going to change to IC. CO3 2 minus is carbonate. So we are going to do a very simple thing here. I'm going to toss ATE and add to the name IC. Therefore, it's going to be carbonic. And then leave a gap and add the word acid. Therefore, H2CO3 is named carbonic acid. Now let's see H3PO4. Again, we have hydrogen, an element, and oxygen. Therefore, this is an oxoacid. First thing is to identify the oxoanion. Very simple. Exclude the hydrogen, and the rest of the elements will give you the oxoanion. Therefore, what we have here is PO4, and we know from Nick the Camel that PO4 has a charge of 3 minus. Okay, so it is right here. PO4 3 minus is a phosphate. When it is combined with the hydrogens, we are going to toss the ATE ending, and in this case is going to be called phosphoric. And because it is an acid, we have to add the word acid. Therefore, H3PO4 is named phosphoric acid. Okay, so oxoacids are not easy. And of course, you are not going to master at the first glance. So that will require some training. And that's what we are going to work towards in the discussion section. Okay. So one thing that I would like to tell you, it's very tempting when you have an exercise to open an extra tab in your computer and Google the name. I will not tell you to don't do that because it's up to you. If you do that, you will get the answer. However, this course will progress and you need to know the basis to get to the more advanced thing. So you have to try really hard to learn how to name things and from the name get the formula, because that will help you later on in the course. If you don't do that, you are going to waste a lot of time looking for answers and will not have time to finish the questions that will show up in the future. Okay, so sometimes you have to take one step backwards to get 2 steps forward. I don't care if you don't do well right now, but try to learn it, and that will help you in the future. Okay, so with that, I think that's more than enough for today, and I will stop here, and we'll see you tomorrow at the discussion, and then again on Wednesday. Okay, thank you very much. Hope you have a good week.
Thank you, George.
Thank you.
Bye-bye.
Have a nice day. Have a good rest of your day.
Have a good day.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye. Thank
Thanks,
you.
Professor.
Thanks, Professor.
Bye-bye.